So before I begin, I have to explain this title. You deserve an explanation. So in 2001, I discovered the JSON data interchange format, the world's best loved data interchange format. 4 years later, it became an overnight sensation because of the Ajax revolution. 2 years later, I was asked to keynote at XML 2007 in Boston. So I'm wondering, okay, what am I going to tell them? You guys are deeply emotionally attached to the wrong technology. Your technology is making your lives much more difficult. You have no idea how miserable you are. You need to. I think nobody wants to hear that, right? You know, even if it's true, you know, that you don't want to hear that. So I suggested, okay, instead of doing a keynote, let's do a panel. You know, and we'll put a couple other guys on. So I can just say the truth, and they can say things that are familiar and comforting, and everybody can hear what they want to hear, and we'll all have a pleasant evening. So, so that's what we did. The first question I was asked was, does XML have a future? I said, well, of course it does. Because once something gets into the enterprise, it can take decades to get rid of it. So, you know, there's still shops that are running COBOL. So I got to figure we're going to be stuck with XML for a long, long time. So we finished the panel, and during the Q&A, one of the delegates stood up and said, "We welcome our JSON overlords." Okay, so it's now 5 years later, and I'm at a Java conference keynoting about JavaScript. Incidentally, last year I met a guy who was working at a major university, and he said they're still doing COBOL there. And they're hoping maybe someday they can migrate to Java. I said, well, that must be like working at Colonial Williamsburg. And he didn't think it was funny. I don't know. You know, this is how we churn the butter, and this is how we prepare the quarterly divisional expense forecast reports. So anyway, I'm here to talk about JavaScript, the world's most misunderstood programming language. It has been misunderstood from the very beginning, and misunderstanding continues to expand. You know, people think all sorts of crazy things about it, in particular that it's Java's little brother. That's still people who think it's a subset of Java, or that it's interpreted Java, which doesn't make sense because Java is interpreted Java. It's a different language with a weird history. So it has become the world's most popular programming language. There are more people writing today in JavaScript than anything else. You could argue most of those people should not be writing in any language, and you're probably right. But the fact is, it's not Visual Basic anymore, it's JavaScript. That's who's doing it. At the same time, it is the world's most unpopular programming language, in the sense that if you ask any group of programmers, what language do you hate the most? By far, the most common answer is going to be JavaScript. And that'll include people who have never used it, who hate it simply because it has become more popular than their favorite language, and it includes a lot of people who are using JavaScript themselves because they have some fundamental misunderstanding about it. For example, most web developers hate JavaScript because of the DOM, which is the API that the browser presents to JavaScript, which is not JavaScript. The DOM is one of the most hateful APIs ever invented. So if you were to take your favorite programming language, remove all of the standard libraries, replace them with the DOM, you would hate that language. And that's sort of the state of the art in the browsers right now. One source of misunderstanding is that JavaScript is a language that people will use without learning it first, which is a mistake that you would not make in any other language. You know, okay, I'll write this in JavaScript, but there's no way I'm going to know what I'm doing, and people feel good about that. You know, out of principle, I'm just not going to know what I'm doing. JavaScript is the only language that people will make this mistake about. All other languages, you got to know what you're doing. And it's true in this one too. It's just, it happens to be more forgiving than most languages. So give us a little historical context. You all remember 1995, that's when Java appeared. Java applets looked like they were going to take over the world. There was huge interest at that time in Java applets and how they were going to destroy Microsoft. Java applets were the biggest failure in the history of software. This is not generally well remembered in the Java community, but it is true. Flat on its face, total failure, Java applets. They don't exist anymore in the web. Java exists mainly as an attack vector. It's not used for application delivery anymore. So another thing that happened in 1995 was Netscape. They had, at that moment in time, the most successful IPO in history. They had a browser that was cloned from something that was developed in Illinois and no business plan. And they shot way up. Thank you. Netscape and Sun were both promising that they had new platforms that were going to destroy Microsoft. And they decided they should probably work together. Otherwise, Microsoft would play them off against each other and they'd both lose. Netscape agreed with Sun that they should put Java into their browser because, why not? But they also remembered HyperCard, which was something that had been popular 10 years before. HyperCard was this amazing thing developed by Bill Atkinson at Apple, which allowed for non-programmers to write very sophisticated event-driven applications. And Mark Andreessen and others at Netscape wanted to do the same thing to their browsers. They wanted beginners to be able to write sophisticated applications that would run in the browser. And they knew that Java was not the language that would let them do that because a beginner cannot write hello world in Java. You need way too much knowledge just to get started. They want something with a much lower barrier to entry. So they hired this guy. This is Brendan Eich. This is the guy who's responsible for JavaScript. He was a kernel hacker at Silicon Graphics, but he had a big interest in programming languages. At the interview, he mentioned that he was getting to write an interpreter in Scheme because he wanted to learn more about Scheme and how that worked. And he suggested that that might be a good language for their browser because Scheme can be really small, but it's extremely powerful. It's one of the smartest programming languages ever invented. And the guys at Netscape thought, wow, this guy's really smart. We should hire him and have him do this. Now, before he started work, somebody at Netscape found out what Scheme was. So on his first day at work, they said, no, you can't do Scheme. People don't like Scheme. It's got the parentheses and everything. We want a language that people like. So make it look like Visual Basic or Java, something popular. So he threw away his design, started over, created a new language in 10 days. Design implementation in 10 days in May of 1995. An amazing accomplishment, but 10 days is way too short a time to develop a programming language. There's some brilliant stuff in there, a lot of mistakes. And very quickly, as people started using the language, he lost the ability to correct the mistakes and they shipped it as it was, which is pretty awful. The code name of the project was Mocha at that time. They were unable to get a trademark clearance on it, so they had to change the name. So Brendan took syntax and some other features from Java, also borrowed features from Pascal and Perl. Those were all generally very bad parts. He took some features from Scheme, took some features from Self. These are two research languages, very highly regarded among language designers, but not well known to the mainstream. And it was pretty audacious for him to take features from these research languages to put into a language for beginners. That was quite an astonishing thing to do. And the name of that language initially was LiveScript. Sun insisted that LiveScript was an embarrassment because the world only needed one programming language from that day on, and that was Java. And there was no excuse for why this other language was in there. Netscape refused to remove the language, both because Java didn't work for the mission they had intended it to, and because they couldn't afford the engineering costs at that late date. So it looked like there was going to be an impasse and their alliance was going to break down when Mark Andreessen suggested, maybe as a joke, that they change the name of the language to JavaScript, and that they tell the world that it isn't a different language, it's just a subset of the other language, it's its stupid little brother, and that'll be our story. So Netscape and Sun went out and intentionally lied about what the language was. And echoes of those lies are still going on today. One other wrinkle, some said, well, okay, but as long as it has the word Java in its name, we own the trademark. And so they took control of that and gave Netscape a license to use that trademark. Microsoft took notice of these two companies in California that were getting ready to destroy it. So they decided we need to get into the browser game. So they bought Spyglass and started work on Internet Explorer 1 and reverse engineered JavaScript. And they did the most careful, professional, detailed, disciplined bit of reverse engineering that has ever been done at Microsoft. They found every bug, every error, every design defect that Brendan had put into JavaScript, documented them, and replicated them. And they couldn't call it JavaScript because that was a Sun trademark and they weren't getting along with Sun very well at that time. So they called it JScript. Netscape took notice of that and thought, oh my God, we're going to get embraced and extended. We need to get a standard. They went to W3C and said, we invented this programming language. Would you like to standardize it? Turns out W3C had been waiting for an opportunity to tell Netscape to go to hell. So they told Netscape to go to hell. They went to ISO. They went all over. Eventually, they went to the European Computer Manufacturers Association, ECMA. And ECMA agreed to make a standard out of it. But at the first committee meeting, Microsoft took control of the process and insisted that every one of those errors that they so carefully discovered and documented goes into the standard. And so that happened. They also had to come up with a new name for the standard because JavaScript was a trademark of Sun, and so they couldn't use it for the standard. So after a bunch of false starts, they eventually called the standard ECMAScript, which is maybe the worst name ever put on a programming language up until maybe Java FX script. And so there's still confusion. Some people think that all of these names represent different distinct things. But they're all synonyms. It's just 3 or 4 names for one silly language. So Netscape sort of self-destructed by 2000, eventually got bought by AOL, which they used for negotiating leverage against Microsoft. In 2000, George Colony of Forrester Research predicted that the web was about to die. Another software technology will come along and kill off the web, just as it killed news, Gopher et al. And that judgment day will arrive very soon in the next 2 to 3 years, not 25 years from now. Now, if you go to Forrester's website, you can't find this anymore. But it is on archive.org. So Colony's point was that a system which did nothing except deliver static pages, static documents, was doomed, that the next step forward was going to be something that is capable of delivering applications, what he called the X-Internet. And Microsoft believed that, so they disbanded the IE team and put them to work on Avalon to build that very thing. And a lot of other people did too. The surprising thing that happened was that it turned out the browser was always capable of doing application delivery because it had JavaScript in it. And so JavaScript is succeeding not just because it is in the browser survived because there was JavaScript in it. And it worked. So JavaScript should have failed at that point when Netscape failed, but it didn't. It survived Netscape. It survived Microsoft's expectation that its browser was going to die because it had good parts in it. It wasn't just the opportunity thing. It wasn't just that it happened to be a language that was in the browser. Java had already proven that that was not a sufficient condition for victory, that there was actually a lot of goodness in it. Now, there's a lot of badness in it, too, because it was done in 10 days and not properly tested. So there's more goodness in JavaScript and more badness in JavaScript than maybe any other language. You know, most languages fall somewhere more in the middle. But its good parts are maybe the best parts ever put into a programming language. I'll tell you about 2 of them. One of them is statically scoped first-class functions with lexical closure. This is the thing that JavaScript learned from Scheme. Scheme was a dialect of Lisp that was developed in order to explore Carl Hewitt's actor model. And Scheme accidentally discovered the consequences of having static scoping in nested functions. It turns out it's incredibly powerful. Those of you who are computer science guys should quickly recognize this is the Y Combinator. This demonstrates that the lambda calculus is capable of doing recursion. Not a lot of practical value here, but it demonstrates that JavaScript is a functional language. So, the best idea that was in Scheme is here. JavaScript didn't get it quite right in the same way that it didn't get anything quite right. The biggest thing it's missing is tail recursion. Hopefully we'll get that fixed in the next edition. But functions are first class. It does all the things that you want in a functional programming language. It's brilliant. Enormous expressive power here. So lambdas first got into programming languages in '58 when McCarthy developed Lisp at MIT, got perfected in Scheme in the early '70s, but the mainstream never paid any attention to it because we just couldn't get past the parentheses. JavaScript is the first language to take lambda to the mainstream. And that's an amazing accomplishment. It is no longer unique. There are a lot of other languages that have followed JavaScript since then, including Python, C#, even PHP is now doing lambdas. There are rumors that maybe someday even Java will do this. So JavaScript is not just an okay language, it's actually become an influential language. It's something that language designers are paying attention to. The other feature is prototypal inheritance. This is something that JavaScript got from self. An object in JavaScript is a dynamic collection of key value pairs. And each object can have an inheritance link to another object. So if you try to access a property from an object and it doesn't have it, you can go see if it inherits it from another object. So instead of having classes, you simply have objects that inherit from objects. Self was a dialect of Smalltalk developed by Unger and Smith at Xerox PARC and then later at Sun Labs, which was exploring an advancement on Smalltalk. Some people look at the prototype thing as being a step backward. It's actually a step forward. It has much more expressive power than the classical model. Turns out to be much easier to program because you don't have to do the classification and taxonomy that's required in class-driven systems. That's all just avoided. You just make objects. It's a more pure object system. It's very expressive. You can very easily emulate a classical system using prototypes. Doing the opposite turns out to be really hard. So it's much easier to write in a Java style in JavaScript than it is to write in a JavaScript style in Java, because JavaScript has more expressive power. It's actually the more powerful of the two languages. So one of the amazing things about JavaScript is that it works for beginners, that people who have no knowledge about programming are able to do interesting stuff. So we see a lot of designers, a lot of web people, people with no formal training in programming are getting a lot of stuff done. And because of its lambda nature, because of its prototypal nature, scientists are interested in this language, and they are doing really sophisticated research in JavaScript, and everybody in between. This is an enormous range. Appealing to either of those extremes is really hard. Meeting both of those extremes at the same time is unique. There's no other language that's able to do this. One of the complaints about JavaScript is that it is slow. Until recently, all of the JavaScript interpreters were optimized for time to market. And that was 10 or 15 years ago, and have been patched and crufted over since then. So they were just barely keeping up with Moore's law. But it turned out for most web applications, that doesn't matter. This is Microsoft's research on how major websites spend their time in the browser. You see most of the time is going to layout and rendering. JavaScript's only taking up about 3% of the time. So if you were to take a JavaScript interpreter and make it infinitely fast, squeeze that to 0, most users are not going to notice. So there wasn't a lot of pressure to make JavaScript engines faster. But that changed when Google started working on V8. Guys who come out of the Self project and the Hotspot project were now working on making JavaScript go faster. For a while, it was thought that JavaScript needed a type system in order to become a high-performance language. That turned out not to be true. It doesn't need a type system. It's fine the way it is. And so V8 started this competition. Firefox is in the competition. Apple's in the competition. Microsoft is doing some amazing work. They're all making their JavaScript engines much faster, which doesn't matter much for web applications, but it is making possible new classes of applications which were not feasible in JavaScript before. They are now becoming feasible. So we see JavaScript being used in real-time games and 3D visualization, things that you wouldn't do before in JavaScript. It turns out to be really good at those things. So as a result of all of this stuff, we're seeing JavaScript everywhere. So it's clearly the language of the browser, and that's where it first came into dominance. But it's now in operating systems. It's a standard feature in Windows and in Mac OS. And there are new operating systems being developed specifically to run JavaScript, things like Web OS, Chrome OS, Firefox OS, and Windows 8. So JavaScript is finding a privileged position in those systems. JavaScript is built into the best databases now. JavaScript is now finding a new home in the server. There's this wonderful thing called Node.js, which takes the turn-based event-driven execution model that is in the browser and putting that on the server. And that turns out to be brilliant. You get really efficient web servers out of that. But even better, it means you can now take one body of JavaScript code and run it in the browser, or run it in the server, or run it in the app. So you don't have to write the thing 3 times. You only have to run it once and put it everywhere. JavaScript is finding itself in mobile. It's the one programming language which is available in all the smart mobile devices. And we're going to see more of that. It's even finding its way into TV sets, which I think is silly, because computer stuff tends to get obsolete really fast, but you expect a big TV to last for many, many years. And so having a quickly expiring component in something that's supposed to be long-lived, I think is ridiculous. But JavaScript is now finding its way into TVs and other consumer electronics devices. One thing that we're starting to see emerging in JavaScript now is high-performance data structures. So in Node.js, there are buffer arrays which allow for quickly moving blobs through the system in JavaScript. So it can handle data in a high-performance way. We're seeing byte arrays in browsers which can take data and push it down into WebGL so that GPUs can now have a high-performance interface to JavaScript, which allows for very fast 3D graphics. Intel recently demonstrated something that they call parallel arrays, where they've got an immutable array that's full of interesting values, and it has interesting methods like a map method. So you can pass a JavaScript method to the map method of one of these arrays, and it will distribute the invocation of that function across all of the cores that are available to it. So we can now do very, very fast multi-core operations in JavaScript. This won't be in the next edition, but hopefully will be in the edition after that. JavaScript's becoming a high-performance language. One of the problems with JavaScript, particularly in the browser, is its performance problems, or I'm sorry, its security problems. And there's been some interesting work there. For example, Google's Kaha is a JavaScript to JavaScript compiler, which will add a lot of indirection and case checking to make sure that a piece of third-party code cannot break out of its containment. So that's the first step towards solution of the mashup problem. My own AdSafe system does a similar thing without the need for code rewriting. So it's more efficient, but they're both based on the same capability model. Things that were learned in the Kaha and AdSafe projects were fed into the ES5 project. So the strict mode and other features in ES5 are there in order to help us make the JavaScript a secure programming language. Google's doing some really interesting work advancing that idea, something called distributed, resilient, secure ECMAScript. or Dr. Sess, which combines secure JavaScript with the actor model in a fully distributed way, which allows JavaScript to migrate out into the cloud and be the language that goes everywhere with an inherently powerful security mechanism built in. Really wonderful stuff. But the most amazing, unexpected thing is that JavaScript has become the universal virtual machine. We always thought that the JVM would have that role. It turns out it's JavaScript. It turns out that the JavaScript parser does a better job of code security than the JVM's bytecode verifier. And because it's a higher level language, it's actually an easier thing to generate code for. So the first of these was Google's Web Toolkit. Google is translating Java into JavaScript so that it can run everywhere. Amazing. I don't really get this myself because JavaScript is actually a better language than Java is, particularly for the sorts of highly interactive applications that we do on the web. And you don't get any of the benefit of its good parts if you don't know that you're in that language. So as a result, but on the other hand, there are a lot of people who really like the idea of not having to learn anything or change their mind about stuff. And Gwt is perfect for people like that. And so it's finding a big following. But it turns out there are a lot of other languages that are doing this too. This is the most interesting one for me. This is something that was developed at Princeton. SpiderMonkey is the JavaScript engine that was developed at Mozilla. It's the thing that's in Firefox, and it's written in C++. You can give that to Clang, and it will produce a LLVM file. You give that to Inscripton, it turns it into JavaScript. Not very good JavaScript, but it's JavaScript. It runs and it works. And then you give that to Google's Clojure compiler, which turns the crappy JavaScript into better JavaScript. Clojure does heroic things and some kind of terrible things in order to make the code as small and as fast as possible. So it then becomes feasible to run. And that produces something called js.js, which is a true JavaScript emulator that is written in JavaScript, that runs in JavaScript, which has no dependencies on any of the JavaScript environment. Yeah, it's amazing. Who would have thought you could do this stuff? Suddenly, there are a lot of new languages being developed specifically to run in JavaScript. So there are over 100 of them. The most interesting one is, and most influential one is CoffeeScript. CoffeeScript takes JavaScript, removes all the bad parts, so it just keeps the good parts of the language, removes the Java-flavored syntax, replaces it with a brand new syntax, which is really lightweight, really expressive, and nice. It's been said that no language can succeed unless it has curly braces and looks like C. And CoffeeScript is saying, no, that's actually not true, that you can come up with a wholly new syntax without curly braces and without semicolons, and it's great. And it's inspiring a lot of other people to develop variations on it and wholly new languages. A lot of interesting activity there. But even more surprising is that old languages are now being translated to JavaScript. This is a subset of a lot of the languages that are being done. Some of these are not finished yet, but some of these have multiple professional implementations like C# and Java. So it's now a viable thing to take languages or programs written in pretty much any language and move them to JavaScript so they can run everywhere. It's amazing. So that's putting some pressure on the design of the language to become a better compilation target. JavaScript has a small number of control structures, and if you have a language that doesn't exactly map onto those structures, the code you have to generate is kind of awkward. So there have been demands for adding goto to JavaScript. And that's something we don't want to do, because it took us a generation to realize we didn't want it. And if we put it back in, we can't put it in just for the compiler writers, because the web developers will find out, hey, did you know you can do goto? And then we'll be stuck with it for at least another generation. So we don't want to do that. But we are going to add tail recursion optimization in the next edition, which is great, because it turns out that if the last thing a function does is return the result of calling another function or itself, you can change that JSR ret sequence into a jump, and jump is a go-to. So it gives us a very structured, elegant way of adding Go to the language, which also has lots of other benefits. It allows us to do continuation passing style and other things. So that adds even more expressive power to the language. So unexpectedly, I mean, nobody expected this. JavaScript has become the most important programming language. It's the most future-facing of everything that we've got. Nobody wanted this. It just happened because it had all this goodness in it. And there was a lot of luck, too. So I got to wrap up. So before I do, I just want to say one thing. So a personal note. I never wanted to be the JavaScript guy. And it wasn't like I decided, oh yeah, that language, that's the thing. I got to get behind that. I got to be someone who's known as knowing something about that, being an advocate. The first time I saw JavaScript in 1995, I thought, this is the stupidest thing I've ever seen. I said that. And I was pretty confident that I was right. 5 years later, circumstance and having spent $20 million trying to develop a Java client application that took 3 minutes to load convinced me that I needed to take another look at JavaScript. And in looking deeply at it, I discovered it's got lambdas in it. And suddenly all of this potential opened up. And so I started writing about how this language is misunderstood, and I became the JavaScript guy. And I'm still not comfortable in that role. It's still not what I ever wanted to be, but I seem to have been stuck with this language. And that's likely to continue because the language is becoming even more important, so this isn't something I can get away from. I sincerely hope this is not the last language. That would make me really sad. I mean, there are other languages that we see that are quite amazingly wonderful. I love Clojure. I love Scala. I would like to see those succeed, but both of them have really high barriers to entry, and so they're not available to the mainstream in the way that JavaScript is. I hope somebody else can figure out how to make a language which is really easy to start with, which also scales up to do the wonderful functional stuff at the same time as JavaScript did. I mean, JavaScript got so much wrong, and we have learned the hard way about all of that wrongness. Somebody's got to figure out how to do it right. It shouldn't be that hard. So that's all I got for you. Thank you and good night.